Hello everybody. Today we will learn about the quadrilaterals. Now before starting the quadrilaterals, we have to understand what polygons are, because quadrilaterals are a type of a polygon. Now what is a polygon? A polygon is a closed curve. It is a closed curve made up of line segments. Now there can be a closed curve like this. This is a closed curve. This is a closed curve, right? A closed curve means which is closed. Now this is a unclosed curve, and this is also a closed curve, right? So out of these four closed curve which I have made, this is a polygon and this is a polygon. Why these two graphs are not a polygon? Because this is not made up of line segment. It is a circle. It is not made up of line segment, whereas this is not a polygon because it is not a closed curve. So a polygon should meet these two properties. It should be a closed curve while it should be made up of a line segment. So this is a closed while this is made up of three line segments. This is a closed curve while this is made up of 1, 2, 3, 4, 5 line segments. So we have understood what a polygon is. Now quadrilateral is a type of a polygon which has four sides, meaning it is made up of four line segments. Now it has 1, 2, 3 and 4 sides. So this is a quadrilateral, which is a polygon which has four sides. Now we will understand some of the terminologies. This is a quadrilateral. Now we will understand some of the terminologies which are frequently used in quadrilaterals or polygon, we can say. Now these four are called the sides of the polygon or quadrilateral. So it has four sides, 1, 2, 3 and 4. So these 1, 2, 3, 4, these are known as sides of the polygon. It has got two diagonals. What is a diagonal? This is a diagonal, 1, 2. This is a diagonal. So what is a diagonal? Diagonal is a line segment. It is a line segment connecting two non-consecutive. It is a line segment connecting two non-consecutive sides of a polygon. Or we should say two non-consecutive vertices of a polygon, connecting two non-consecutive vertices, I should say. So this, what is a diagonal? This is a diagonal. So what is a diagonal? It is a line segment. So these are called the vertices of a polygon, right? 1, 2, 3, 4. Let us rename A, B, C and D. So A, B, C and D are the four vertices of a polygon. These are called the vertices of a polygon. 1, 2, 3, 4 are called the sides of the polygon. A, B, sorry, C and D, it should be D. Are called the sides. Over here 1, 2, 3, 4 are the sides. A, B, C, D are the vertices of the polygon. Now what is a diagonal? Connecting two non-consecutive So A and C are the two non-consecutive. These A and B are the consecutive vertices. A and C are the two non-consecutive vertices. So if we connect A and C with a line, this red line is called a diagonal. Now again B and D are the two non-consecutive vertices of a polygon or quadrilateral. So if we join B and D, it becomes a diagonal. So this quadrilateral has two diagonals, A and C, AC, comma, BD are the diagonals, right? Now these are the frequently used terminologies, right? Also, let us redraw this figure once again, redraw the quadrilateral. So over here A, B, C, D are the vertices. 1, 2, 3, 4 are the sides of the quadrilateral. We have also 4 angles inside in the quadrilateral. So these are the 4 angles. These 4 angles are the interior angles. They are interior angles. So let us rename them as A, B, C, D, small. So angle A, angle B, angle C, angle D are the interior angles. These are known as the interior angles. And let us look at the exterior angles. Now we will learn what exterior angle is. See this angle, double line. Now we will rename it X, P, Q, R, S. P, Q, R, and S. These are the exterior angles. Angle P, angle Q, angle R, and angle S. These are the exterior angles of a polygon or quadrilateral. Why exterior angles? Because they are outside the quadrilateral. Okay, so how to find an exterior angle? Just extend the line and the angle made up with the help of extending a line and the adjacent line, right? This is a exterior angle. Now angle A plus angle P should be equal to 180 degrees, right? Over here angle D, so this whole is a line, so angle D plus angle Q, angle D plus angle Q should be equal to 180 degrees. Angle C plus angle R should be equal to 180 degrees, and angle B, it is B. Angle B plus angle S should be equal to 180 degrees, right? So we have learned what are polygons, what are quadrilaterals, what is a line, what are sides of the quadrilateral, what are the vertices of the quadrilateral, what are the diagonals of a quadrilateral, what are the interior angles of the quadrilateral, what are the exterior angles of the quadrilateral. Now we will see what is a convex and a concave polygon, right? So convex polygon and concave polygon. So a polygon having all the vertices, all the angles of inside it, or we should say all the interior angles of the polygon. So interior angles are less than 180 degrees. So all the interior angles of the convex polygon should be less than 180 degree, right? What is a concave polygon? A polygon, if a polygon has see, this is a, sorry, now it goes like this. Now this is one of the angle of the concave polygon. This angle is greater than 180 degree. So if any one of the angle is greater than 180 degree, then it is a concave polygon. We can also, so we should write it over here, that if over here angle, let us say this is angle P is greater than angle 180 degree, is greater than 180 degree. So therefore this is a concave polygon, right? With the help of diagonal also we can find out whether a polygon is a convex polygon or a concave polygon. See, these two diagonals of our quadrilaterals are lying inside the quadrilateral, right? Inside the quadrilateral. Let us draw the diagonal for this particular quadrilateral. See, we will join these two. These are the two adjacent vertices, 1, 2, 3, 4. These two. So this is one of the diagonal, whereas these two vertices are also non-consecutive. So this is one of the diagonal. So over here one of the diagonal is lying outside the figure or outside the quadrilateral. So if any one of the diagonal or any of the diagonal is lying outside the polygon, then it is a concave polygon, right? So with the help of angles we can either we can look at the angles or interior angles of the polygon, or we can look at the angles which is interior angles, or we can look at the diagonals to find out whether a polygon is a convex or a concave polygon. Now one more classification of a polygon is the regular or a irregular polygon. What is a regular polygon? Regular polygon. A regular polygon is a polygon which is equiangular, whereas equilateral. So what is equiangular means? All angles are equal. All angles means all the interior angles of the polygon are equal. So let us take this figure. If all these four angles are equal, that means it is equiangular, right? If all the sides are equal, see, then it is a equilateral. So equiangular means all the angles are equal, equilateral means all the sides are equal. So a regular polygon is a polygon having all the angles as well as all the sides are equal, then it is a regular polygon. Let us look at some of the examples of the regular polygon. See, a square is a regular polygon. Why? This is a square having all sides equal, whereas all the angles are of 90 degrees. So it is a regular polygon. A square is a regular polygon, right? A triangle, equilateral triangle. Can we look at the equilateral triangle? See, equilateral triangle has all the angles as well as all the sides are equal. So therefore this is a regular polygon, right? This is a now let us look at the rectangle. See, rectangle has all the four angles of 90 degrees, right? Whereas it has these two sides of equal and these two sides are equal. All the four sides are not equal, therefore it is a irregular polygon. Although it is an equiangular, it satisfies the property of equiangular, but it is not equilateral, therefore it is a irregular polygon. Right. Now let us look at one more definition, or the angle sum property of a polygon. We all know that for a triangle, all the three angles of a triangle, this is angle A, B and C. We know that angle A plus angle B plus angle C is equal to 180 degrees. So this is known as the angle sum property, because it mentions that the sum of the angles of the triangle is equal to 180 degrees. Now if we look at the polygon, quadrilateral, then what will happen? Just look at we will find out the angle sum property of a quadrilateral. What are we going to do? We are going to find the angle sum property of a quadrilateral. Now let us make a diagonal, right? This is a diagonal. Now these two portions, these are the two triangles, right? These are the two triangles. Okay. Now see, this is one triangle in red area. If this is angle A, B, C, we know that angle A plus angle B plus angle C is equal to 180 degrees, because this red shaded is a triangle. Therefore angle A plus angle B plus angle C is 180 degrees. Again P, Q, R, angle P plus angle Q plus angle R is equal to 180 degrees, right? Now if we add these two equations, so what will we get? Angle A plus angle B plus angle C plus angle P plus angle Q plus angle R is equal to 360 degrees, 180 degrees plus 180 degrees. So we have summed these two equations. Now angle B plus angle P, let us name the vertices A, B, C, D. These are the vertices of the quadrilateral, A, B, C, D. Now angle B plus angle P makes angle A. So angle A plus angle capital A. Similarly angle C plus Q makes angle C. So angle C plus Q, this guy plus this guy, angle C plus angle R is equal to 360 degrees, which makes angle C, angle A is angle B, angle B plus angle A plus angle C plus angle R is angle D is equal to 360 degrees. So we have found that the sum of the angles of a quadrilateral is 360 degrees. So this is the angle sum property of a quadrilateral, which says that all the angles, so if we are given any quadrilateral, then we could say that if x, y, z, this is w, then we can easily say that w plus x plus y plus z is equal to 360 degrees, right? So the angle sum property of a triangle says the angle inside the sum of the angles of triangle is 180 degrees. In quadrilateral, sum of angles of a quadrilateral is 360 degrees, right? We will just solve one question based on this angle sum property to make it more clear. See, let us say we have a quadrilateral. Right? Now, this is angle Y, this is angle X, this is angle 120 degrees, this is angle 80 degrees, this is 60 degrees, this is angle Z, this is angle W. Now we have to find out X in this question. We have to find out X plus Y plus Z plus W. We have to find out the sum of angles of X plus Y plus Z plus W. Now X, Y, Z and W are unknown over here. So we have to find out the values. First we have to find out the values of X and Y and Z and W. We know that this is a straight line. Therefore angle X plus X plus 120 degrees is equal to 180 degrees, right? This whole thing should be equal to 180 degrees, right? Therefore angle X is equal to, we will move 120 over here, 180 degrees minus 120 degrees makes 60 degrees. Now we know angle X is 60 degrees. Similarly over here angle Y plus 80 degrees should be equal to 180 degrees. Therefore angle Y is equal to 180 degrees minus 80 degrees makes 100 degrees. Similarly over here angle Z plus 60 degrees should be equal to 180 degrees. This means angle Z is equal to 180 degrees minus 60 degrees makes it 120 degrees, angle Z. Now what is angle W? See over here, what is angle W? Now we don't know, this angle is not given, so we could not say that, let us say this angle is angle A. Now this A is given, A is not given, as in the rest of the equations we have given 61. Now we will find first angle A so that we can make the equation like in other vertices. What is angle A? Because we know with the help of angle sum properties that the sum of all the angles of a quadrilateral is 360 degrees. So we could write over here AA plus 60 degrees plus 80 degrees plus 120 degrees should be equal to 360 degrees, right? Now with the help of this equation we can find angle A. What is angle A? Now angle A is equal to 360 degrees minus this whole thing. Now this is 260, I think so. This is 260 degrees makes angle A as 100 degrees. Now again over here we can say angle W plus angle A is equal to 180 degrees. Now because angle A we know is 100 degrees is equal to 180 degrees, therefore we can say that angle W is 80 degrees, right? Angle A is 80 degrees. Now we know all the four angles, therefore we can say angle X is 60 degrees plus Y is 100 degrees plus Z is 120 degrees plus it is 80 degrees makes it, see, 360 degrees. So X plus Y plus Z plus W is 360 degrees. This is my answer. Thanks for watching the video.